The inductive reactance of an inductor is given by this expression, angular frequency times the inductance. So this is the frequency. Now, though inductance is a reactive element, but because of the coil resistance, the presence of the coil resistance, it is not purely inductive. There is also resistive element in it. So there is a term, quality factor, that is actually defined this way: inductive reactance over resistance. So the higher the quality factor means it is more, it's purer inductance. So this is defined as such. So any particular inductance, we can find the Q for that, for a specific frequency, and that will define how much inductive we can say. So, but purely it won't be inductive because of the coil's resistance. So we will have a finite value of Q. Now what we have seen for inductance is when the current keeps increasing, the inductance, or decreasing, the inductance doesn't allow to change the current instantaneously. So a work needs to be done to overcome that opposition, and that work is stored as an energy in the inductor. So as we can see that if we say P, which is the power, so we can define it like that, Vi of the inductance. Now V of inductance is L di dt. If we say this is V of the inductance. So if we want to find the energy stored in an inductance for the current to become from 0 to say an arbitrary I ampere, so the ampere is, we have to integrate this thing to find out the energy stored. So from 0 to I it is becoming, and we should integrate this one. This is I, the power Vi and di. So this one V is equal to, I L di dt. That's how it is. So instead of V, I will write, I'll just correct this part. So instead of I L di, so I am trying to find the W here. This one, from this one and this one, I can write this one and I can integrate to find the energy stored. So if I do that, I can take the L out here. This is 0 to I di. So L, integration of that will become I square over 2, I over 0. So L, this is I square over 2. So basically half L I square. This is the energy stored in an inductor for the current, when the current is becoming from 0 to I, or when the current decays from an inductor, this is the energy released.